Have you ever wondered how meteorologists can predict the weather? This isn't just about knowing if you'll need an umbrella tomorrow. Weather forecasts shape our lives, helping us decide what to wear, when to plan that family picnic, even guiding farmers on when to sow their seeds. These predictions, as mundane as they may seem, are crucial to our daily routines. So how do we make them? Understanding this art of prediction requires us to delve into the fascinating world of meteorology. Every weather forecast begins with an observation. Imagine a world of data swirling around us, unseen. That's what meteorologists dive into every day. They gather information from various sources, including weather stations, satellites, and radars. Each source provides a unique piece of the puzzle that is the weather forecast. Weather stations, located across the globe, are the foot soldiers in this data collection task. They monitor local conditions on the ground and report back on the temperature, pressure, wind speed and direction, humidity, and even precipitation. This data is then relayed to meteorologists, who use it to understand the current state of the atmosphere. Meanwhile, satellites, like silent observers in the sky, provide a bird's-eye view of the weather. They capture images of cloud patterns and track changes in sea surface temperatures, among other things. This data helps meteorologists understand global weather patterns and predict how they might change over time. Radars, on the other hand, are the sharpshooters of weather observation. They use radio waves to measure the intensity and movement of precipitation, such as rain, snow, or hail. This allows meteorologists to track storms and predict their path and intensity. But it's not just about collecting data, it's also about understanding what that data means. For example, a sudden drop in pressure could signal the arrival of a storm, while a rise in humidity could suggest an upcoming rain. The type of data collected also varies depending on the forecast. For a short-term forecast, meteorologists might focus on data like temperature and wind speed. But for a long-term forecast, they might look at patterns in sea surface temperatures or upper atmospheric winds. All these data points, collected from across the globe and above it, are pieces of a larger puzzle. Each piece, on its own, tells a part of the story. But together, they form a complete picture, giving meteorologists the information they need to predict what the weather will be like in the future. The collected data forms the basis for the first step in weather prediction. Once we have the data, it's time to make sense of it. And how do we do that? By using the power of mathematics, of course. Weather forecasting is not just about observing and recording data. It's about delving deep into the numbers and using complex mathematical models to decode what the data is telling us about our atmosphere. These mathematical models are a bit like a puzzle. Each piece of data is a puzzle piece, and the mathematical model is the picture on the box that tells us what the completed puzzle should look like. By plugging the data into these models, we can start to see the bigger picture and make sense of the sea of numbers. These models don't just help us understand what's happening now, they help us predict what will happen in the future. They can tell us if we're in for a sunny day or a stormy one, or if we should expect a sudden drop in temperature. But how do these models work? Well, they are based on the laws of physics that govern the atmosphere. The models take into account factors like temperature, pressure, wind speed and direction, and humidity. By applying these laws of physics to the current atmospheric conditions, the models can predict the state of the atmosphere in the future. Now, you might be thinking, that sounds like a lot of data to process. And you're right. That's where computers come in. Computers can process massive amounts of data in a fraction of the time it would take a human. They can run these complex models quickly and efficiently, crunching the numbers and spitting out forecasts in no time. So, in a nutshell, meteorologists gather data, plug it into mathematical models, and use computers to churn out forecasts. It's a combination of science, technology, and mathematics, all working together to give us a glimpse into the future. And that's the beauty of weather forecasting. It's not just about looking at the sky and making a guess. It's about using science to make informed predictions. These mathematical models provide us with a glimpse into the future state of our atmosphere. Predicting the weather isn't just about numbers, it's also about interpretation. Meteorologists are like detectives, piecing together clues to solve a puzzle. They take the output from mathematical models and interpret it, applying their knowledge and experience to paint a picture of future weather conditions. This is the art of interpretation, a key part of the weather forecasting process. The mathematical models are powerful tools, but they're not perfect. They can't fully capture the complexity of the Earth's atmosphere, and they're particularly limited when it comes to local topography, the shape and features of the land. A mountain range, a valley, a river, or an expanse of forest. These features can all have significant effects on weather patterns. And what about the urban heat island effect, where cities can be significantly warmer than the surrounding countryside? Meteorologists need to factor in these local variables when interpreting the model output. They might adjust the forecast based on the known behavior of weather systems in the presence of a particular mountain range, for example, or account for the extra heat in a city. They also consider the time of year and historical weather patterns. Interpretation can also involve making judgment calls. The models might suggest a 50% chance of rain, but is that a light drizzle or a downpour? The meteorologist has to make an informed decision based on the available data. In some cases, meteorologists might consult with their colleagues, sharing their interpretations and discussing possible outcomes. This collaboration can lead to a more accurate forecast. In essence, interpretation is a blend of science, experience, and intuition. It's a human touch that complements the cold precision of the mathematical models. And it's not just about getting the forecast right, it's also about communicating it effectively. Meteorologists need to turn their interpretations into clear, understandable forecasts that people can use to plan their day, their week, or even their year. This interpretation is what turns raw data into a local weather forecast. At its core, weather prediction is a scientific process. A harmonious blend of knowledge and technology. It's an intricate dance of physics, atmospheric dynamics, and computational power. To start, let's unravel the role of physics in weather prediction. The laws of physics govern everything around us, including the weather. They dictate how air pressure, temperature, and humidity interact to create different weather phenomena. By understanding these laws, meteorologists can predict how changes in these variables will influence the weather. Next, we delve into the realm of atmospheric dynamics. This field of study is all about understanding the movements and processes within the Earth's atmosphere. It's like a giant, complex puzzle, where each piece represents a different atmospheric element, like wind speed, cloud cover, or rainfall. Meteorologists use this knowledge to understand how these pieces fit together to create the weather we experience. But knowledge alone isn't enough. To make accurate forecasts, meteorologists need powerful technology. Enter weather satellites, radar systems, and supercomputers. These tools provide real-time data about the state of the atmosphere, allowing meteorologists to monitor weather conditions across the globe. Supercomputers, in particular, play a vital role. They crunch through billions of data points and run complex mathematical models to generate detailed weather forecasts. Over the years, advancements in these areas have significantly improved the accuracy of weather forecasts. Improved understanding of atmospheric dynamics has led to more accurate models. More powerful supercomputers can process more data faster, leading to more timely forecasts. And advancements in satellite and radar technology have provided meteorologists with more accurate and detailed data. Together, these improvements have made weather prediction a more precise science than ever before. In essence, weather prediction is a testament to human ingenuity and our quest for knowledge. It's a perfect example of how science can be harnessed to improve our lives and help us navigate the world around us. Science is the backbone of weather prediction, making it possible for us to plan our lives around the weather. As our understanding of the atmosphere and our technology improve, so does our ability to forecast the weather. Imagine a world where weather forecasts are as precise as a Swiss watch, where we can predict the exact time a raindrop will fall on a particular street, or the precise moment a hurricane will make landfall. This is the future we are heading towards, thanks to advancements in weather prediction. Firstly, data collection is becoming more comprehensive and precise. Satellites, weather balloons, and ground-based stations are constantly being upgraded to provide more accurate data. Soon, we might even see drones and autonomous vehicles contributing to this wealth of information. Secondly, our mathematical models are becoming more sophisticated. These models, which simulate the Earth's atmosphere and predict its changes, are constantly being refined. They're like the crystal balls of meteorology, growing clearer with each new algorithm and equation. Lastly, we have the rise of powerful computers. Weather forecasting is a data-heavy task. The more data we have, the more processing power we need. Thankfully, computing technology is advancing at lightning speed, enabling us to process colossal amounts of data in a fraction of the time it used to take. These advancements are not just about predicting when you'll need to carry an umbrella. They're about saving lives, protecting property, and helping us understand our planet better. In the ever-evolving field of meteorology, one thing remains certain. The future of weather prediction is bright.